It's working.
Okay. Hi, everybody. Thank you for coming to our webinar today. We will be talking about graywater and its uses. Our speaker for this afternoon is Dr. Sybill Sharvelle, and she is an associate in the Department of Civil and Environmental Engineering at Colorado State University, and she is an extension specialist focusing on animal environmental systems, ag waste management, and urban water conservation. My name is Kara Harders, and I am a small acreage management coordinator in the southern region of Colorado out of Canyon City. This video is being made available and recorded by Colorado State University Extension, the National Resource Soil Conservation, and the Master Gardener Program. This webinar will be recorded and it'll be available on our website at Small Acreage Management at Colorado State University. It currently is going to be password protected for a little bit while we work on getting closed captionings made. And so if you go to the website and you want to watch the webinar again right away, you'll have to request a password from Ruth Wilson, and she will get that to you. You just won't be able to get it at it immediately without that password. All right, and I will give it to Sybill now, and she will start with her presentation and teach you guys all, hopefully, everything you want to know about graywater.
Okay, thank you everyone for attending today, and hopefully I do get your questions answered, and if not, certainly we'll be happy to entertain any questions people have at the end. So use of graywater is now legal in the state of Colorado. House Bill 1044 passed in 2013 that provided legislation to allow graywater, and then a regulation came into place on graywater, which I think was passed in 2015. So again, that piece of legislation allows graywater use, and a lot of the education and outreach activities around that were provided by Dr. Larry Rossner, who was a faculty here at CSU that's now retired and a professor emeritus, and myself. Dr. Hickenlooper actually came to CSU to sign the bill, and there's a picture of him doing that signing. So Colorado is now on the map for allowing graywater use. These are the states that have some type of legislation or regulation to allow graywater. And most of these states, as you can see, are in the western region of the United States. There's also some in the southwest and a couple hanging out there in the northwest, like Wisconsin, Maine, and so we were the last western state. Colorado was the last western state that has allowed graywater use, and the reason that it did take a little while longer here was kind of getting over some of the water rights that are associated with use of alternative water sources. Okay, so I do have to go back here and show this picture of Hickenlooper signing the bill. So remember we talking about that, and then real quickly there was that map that I discussed. And now on to basically what we're going to be covering today. So I'll talk about what is graywater and some of the benefits that can be achieved by its use. A summary of Regulation 86, which is the regulation that came out to allow uses of graywater. And then I'll talk about graywater systems for irrigation and how those can be set up, and graywater impacts the soil and plant health that can be associated with those irrigation systems. And finally, I'll also talk a little bit about the graywater systems that can be used for toilet flushing. Okay, so starting right off with what is graywater. So graywater is going to be all of the wastewater generated in the home, excluding the toilet water and the kitchen water. So what it does include is shower and bath water, laundry water, and water from hand wash sinks and wash basins. So by excluding toilet water and kitchen water, you're excluding the water that's more highly contaminated. Sometimes people do ask, why do we exclude kitchen water? Because that could be not as contaminated as toilet water. However, there's a really high organic content of in kitchen water resulting from food, particularly when there's garbage disposals. But even when there's not garbage disposal, just rinsing from plates and things results in really high organic matter and the potential for foodborne pathogen if eggs or raw meat or anything like that is prepared in the kitchen. So it's a water source that needs a higher level of treatment than those other gray water sources like laundry and shower water. Okay, so here's a pie chart of the uses of water inside the home. And you can see if we look at those sources of gray water, the shower, clothes washer, and some portion of the faucets, so we're going to capture hand wash basins, but not kitchen faucets, then it's near to 50% of the wastewater that's generated in a home. And then you can also see that toilets are about 27%, so you can meet all of your toilet demand with gray water and still have some water that could be used for toilet flushing, or sorry, for irrigation. Okay, so because gray water is about half of the water demand that's in gray water is about half of the water that's generated from wastewater in the home, there's a large potential for water demand reduction through gray water. So for example, Colorado's Front Range population is expected to grow from 4.3 to 6.2 million persons by the year 2035, increasing residential water demand by 285,000 acre feet per year. And use of residential gray water for toilet flushing and landscape irrigation in new housing developments alone could reduce this demand by 30%. So the realized water savings of 85,000 acre feet per year out of that 285,000, which represents a significant reduction in that water supply gap that's been identified in the Colorado Water Plan. And it also reduces household wastewater flows by up to 50%, which can provide some benefit in terms of needing for new infrastructure to support all of this population as well. Okay, so Graywater Quality, what is in Graywater? So primarily it's the major constituent in Graywater is really going to be the soaps and detergents that we use in our household products. That results in some organic content in gray water. So this table compares gray water quality to domestic wastewater that includes toilet and kitchen water. So our measures of organic matter are the first two on the top, biochemical oxygen demand or BOD and chemical oxygen demand. You can see that those are quite a bit lower than what we have in domestic wastewater, but still present. Gray water has some nitrogen and phosphorus present, but those are lower concentrations than what are in wastewater, but can be beneficial when we're considering plant growth as well. We do see indicator organisms in gray water, which means fecal matter does ultimately end up in gray water. So when someone washes their hands after using the restroom, then there's potential for those that material to enter into the system. So we do have to take proper precautions to make sure that we protect human health when using gray water. Of course, those are much lower than what we see in domestic wastewater. Okay, so let's talk a little bit more about Regulation 86. So like I said, Regulation 86 allows for gray water use, and it has both uses for irrigation and toilet flushing included within it. And one key thing that was present in the legislation that allowed gray water was that cities could choose to adopt ordinances to allow gray water, or they could select not to. So at this time, the only city that actually has an ordinance written to allow gray water use based on these regulations is the city of Denver. Other cities are, I think, working to develop ordinances, but have not done so yet. So that's one consideration. And the legislation was written to not force cities or counties to allow gray water use and to have that be a choice for that particular city or county. So these regulations are separated into these four categories, A, B, C, and D. And A and B are irrigation categories, and C and D are toilet flushing categories. So in each of these two end uses, we have them, they're categorized based on scale as well. So the type A systems are single family, whereas type B systems are non-single family. And then C is single family for toilet flushing, and D is non-single family for toilet flushing. So there's different requirements for these different categories, and those are based on the kind of risk level that's associated. So the idea is that in a single family residence, there's a lot of exposure to illnesses that may occur there, and so there's a lower risk of gray water being a source of illness there, whereas in a non-single family or multi-residential type of unit, when many people are contributing to the system and many people are making use of water from the system, then there's more regulation that needs to be put in place to be protective of human health. So really with the irrigation systems, there's laundry to landscape allowed, and also storage with filtration. And then for toilet flushing, there's what's called National Sanitation Foundation certification, which I'll be talking more about later. But this just kind of summarizes the uses that are allowed through our regulation and how they are, how the permitting process is different between single family and multi-residential or commercial scale systems. So for the irrigation component, there are many best practices that are included within the regulation. The regulation does not have a lot of specifics in terms of the type of system, but has a lot of best management practices that are coupled with it. And that's a common practice in many states, is to include these best management practices that users of gray water would be educated on. The first one of those, and these are really just common sense practices to prevent exposure to gray water when it's not treated, which is the typical approach that would be used in a single residence household. So the first one of those is no spray irrigation. So since there is that potential for pathogens, you don't want to spray irrigate with gray water unless it's been treated to meet a certain quality that would make it appropriate for that. But with untreated gray water, you're going to be using drip lines or buried distribution lines for your irrigation. And you want to prevent human contact with gray water and the soil irrigated with it. Like we talked about earlier, not including kitchen water. No runoff from the property where the gray water is applied. Currently, it's not allowed for food crops except for citrus and nut trees. And there shouldn't be standing water in the gray water irrigated areas. So there's many other types of best management practices that are linked with these regulations, and in general for gray water systems. These are kind of just the most important ones. Okay, so let's look more at how these systems look. Okay, so those are some landscape types. So the first kind of gray water irrigation system is a really simple system that's easy to retrofit homes for. That's called a laundry to landscape system. So in this system, there's a washing machine, and it makes use of the pump that's already in your washing machine to pump water outdoors into these mulch beds. Several cities in California have had programs where they actually incentivize and provide the equipment for this type of system. And again, those are buried lines that go out into the mulch beds. Other systems can collect all of the household gray water, so from other sources like bathtubs, showers, and hand wash sinks, store that gray water in a tank, use some filtration. Our state requires the 60 mesh filtration, and then supply that water out to drip irrigation systems. So the second type of system is a little bit more complex, but it also enables use of more of the gray water that's generated in a home. Okay, so let's start with these laundry to landscape systems. I mentioned that there's several cities in California that subsidize these. So San Francisco is one of those. Long Beach, California has also done it, as well as Los Angeles. So what they do is they provide a $112 subsidy toward a $117 kit, and they also provide workshops that provide education on how to set these kind of systems up, and they have a toolkit that people can rent for installation. They have several types of guidebooks online as well for how to do these, so those can be a really good resource if you're interested in this kind of system, which is legal and allowed through our state regulation 86. So like I said, these systems make use of a pump on the that's already existing in your washing machine, and when that drains, the water gets pumped to outdoors, and you can see here it's basically going into these different mulch basins, and so water can be distributed to these areas. There's often valves throughout the yard, so you can turn a certain part off maybe for one load of laundry and let one part of the yard be irrigated, and then turn that off for your next laundry load and let the next load go to a different area of the yard. So these are pretty simple systems, and they really don't require a lot of retrofitting in the home. You can just, if you can connect an irrigation system to it, then you can get going with that without renovating in your home at all. Oftentimes when people do these, they do end up doing a lot of new landscaping in their home when they get these new irrigation lines set up. Oh, so these are the valve boxes. And this is an actual picture. So last picture we had a schematic of how those looked, and then here's the valve that comes out of the laundry machine here. And the way that that would be set up would be there's a valve there that if you do run a load of laundry that may be highly contaminated, so if you're washing some soiled clothing or maybe diapers or something of that sort, you may want to divert that to your sewer still. So there's that valve, so you can make a choice of whether your gray water at that time would go to the sewer or to your landscape irrigation system. And then these are pictures of these kinds of mulch basins and the piping that would go to supply the water into those. And so you can see here how these pipes kind of go, or they kind of go around the irrigation area, and then they supply water around the landscape and get that water distributed there. So that kind of is the laundry to landscape system, which, like I said, really doesn't require a lot of retrofitting in the home. Now, if we want to look at trying to collect all of the gray water in the home, then there's these different sources, like we've talked about, the laundry, sinks, the bathtubs, and you can also collect all of those in some kind of storage tank. Then that water can be used either for flushing toilets or for landscape irrigation. But as you can see here, it would oftentimes require some retrofitting. In new construction, it's pretty simple to just separate these collection systems for gray water and black water. However, when you're dealing with existing homes, typically your bathtub and shower and bathroom sink combined with the toilet right in the bathroom. So a lot of times you're breaking into drywall and things to get all of your plumbing separated. Now there can be some easy to access sources of gray water as well. Okay, so this is what these kind of systems can look like that include collection of all of the gray water, and this shows a picture of a storage tank. Oftentimes those storage tanks are going to be something like 100 to 200 gallons, about the size of a water heater that you would have in the home. And so your gray water is collected here in a tank, and this one's in a basement, which would be pretty common. Some people sometimes also have these outdoors outside, either on a ground surface or below ground. And then here's the kind of components that are really needed. This is a coarse filter, about 60 mesh, and then there's a pump that's required to pump that water out into a drip irrigation system. An important component that you see down there too is also the drain. So you need to have a drain in your system, particularly here in Colorado, where we have a season where we wouldn't be irrigating. You would turn on your drain your tank, and allow the gray water to then just go to sewer for that duration. But also, if you have to maintain your tank at all, or do any sort of activity, or if you just don't want to use the gray water, you need to have a drain to allow that to still go to sewer. Okay, so here is another kind of gray water system. This is manufactured by a company in California called ReWater. And this one includes a sand filter, that's that kind of black tank that's shown there, and then also has buried irrigation systems, buried water supply systems with these kind of emitters that you see here. So these black cones that you see are the emitters. Those are designed in a way that they can be planted under a grass area and that the grass roots would not get into the emitters. So one of the problems when you have drip irrigation in grass areas is clogging from the roots. And this kind of system, when placed down like this, does not allow the roots to get up and clog those. So that's a pretty nice system. This particular one that I took a picture of, it had been installed for 8 years with those kind of emitters underground, and they had no maintenance or problems with that system in the time that they'd been running it. Okay. So one question that comes up a lot when we talk about gray water use for irrigation is, what is it going to do to the soil? Is it bad for the environment? What happens to all those soap products? How does it impact plant health? So I wanted to talk about some of those aspects as well. This is actually a house in Colorado that's been using gray water for almost 10 years now. And this is the landscape area that they use the gray water on. And we always like to point out this Rose of Sharon here that's in very good health. So this was nice. We did a national study on gray water use for irrigation and its impacts to soil and plant health. And this was a really nice control area because the neighbor was irrigating with municipal water and there was some similar landscapes, so we could really compare gray water irrigated areas to areas that were irrigated with municipally supplied potable water. So that study is actually documented in this report from Water Environment Research Foundation. This is something that is freely available online, so you can, if you go to the WRF website, you can download that report. It has a lot of technical details if you're interested in going beyond what I talked about today. Okay, so plant health. I mentioned already that Rose of Sharon that's doing really well. All of the grasses that we tested did really well. Most landscape that we looked at in this study, and it was a national study where we collected samples of soil and plants in several states, including California, Texas, Arizona, Colorado. Those were the major ones, I think. But there were a couple of plants we identified as being sensitive to gray water. So one of those was the avocado. You can see there's some tip burn and on the leaves there, and we found also that the plants were not producing as much fruits, if fruits at all. So actually the one on the left is irrigated with potable water, and that one has some issues as well. So there's probably some general soil health issues in this area, but ultimately the photo on the right, you see no fruit essentially associated with that, and that one's not doing so well. Lemon trees we also found to be sensitive, and Scotch pine. So there are landscape recommendations when you're using gray water. Just some summary of the results from this study in terms of impacts to the soil and plant health. Really, there were no major concerns that were noted for use of gray water for irrigation. We found a couple of those types of landscape plants, or even fruit plants that were sensitive, but there were really no major concerns of all of the things that we studied in terms of either soil or plant health. Okay, so a couple of things. We did see salts, boron, and antimicrobials do accumulate in gray water irrigated soils. So antimicrobials are present in a lot of hand soaps and kind of marketed to kill viruses and bacteria. However, those do kind of persist in our environment, and we found that areas irrigated with gray water did have elevated levels of those. Salt and boron as well, and all of these three components can be avoided by best practices. So for example, laundry detergents have a lot more salts when they're powder detergent rather than the liquid detergents. So if you're using your gray water to irrigate landscape, it's recommended that you use more liquid detergent and that you use products that don't contain boron. And potentially, if you're concerned about environmental impacts with the antimicrobials in soaps, then you could select hand soaps that don't include those ingredients. One thing with respect to the salt is that the salt accumulation was not as severe as what we've seen in reclaimed water. So that would be treated wastewater effluent irrigation. And like I said, products low in salt and containing no boron or antimicrobials are really the ones that are recommended. Surfactants are the main ingredient in soaps. Those were a little bit higher in gray water irrigated soils than freshwater irrigated soils. They didn't have an impact on plant health, and they didn't seem to, the soap ingredients didn't seem to leach out of 3-foot columns that we had planted, so there wasn't really much concern about transport of those into groundwater or anything like that associated with these systems. And there's a kind of constant biodegradation of those products. So most of your detergents and soap products are going to contain these surfactants, but they are biodegradable, and the companies have to show biodegradability before they can put those onto the market. So those were not a major concern. No, nitrogen and salts have some potential to leach through soil, so that's one thing that should be considered. And best thing there is to make sure you're not irrigating in areas where the groundwater table is very high. With respect to the kind of health impacts, we didn't see a consistent increase in indicator organisms in gray water irrigated soils compared to freshwater irrigated. There are pathogens, like we said, present in gray water potentially, and therefore to avoid human exposure, drip lines should be used, and we've talked about that already, and all of the states already really have that within their best practices within their regulations. Okay, and then most plants were healthy under gray water irrigation. We had 22 species evaluated, and 3 of those were determined to be sensitive. The nutrients in gray water were really found to be beneficial, and when applying gray water, one should and should really reduce or eliminate fertilizer input, because you're already adding the nitrogen and phosphorus through your gray water source. Okay, so let's talk a little bit about use of gray water for toilet flushing. So gray water systems for toilet flushing have a definite potential for human exposure. So unlike the systems we've looked at so far for gray water use for irrigation, where there was very little, we took a lot of barriers to prevent exposure from humans to gray water. With the toilet, there is that potential for exposure. So we even have the potential that children could go and play in the toilet, or which they do. And we have also, every time you flush the toilet, the reality is we actually ingest some very small quantity of water every time we flush a toilet. So therefore, the treatment for gray water when it's used for toilet flushing is more extensive than what we were looking at for irrigation systems. So there's really never going to be systems that just take gray water straight from its source and plumb it to a toilet. That would be legal, I should say. I'm sure people have those, but they're not legal. So in these kind of systems, you can see we have filtration and a disinfection step, and that disinfection step is there to remove pathogens, bacteria, virus, these kind of things, giardia, anything like that that could end up in that water before it gets to the toilet. Okay, so kind of getting back now to the Regulation 86 and what it allows for toilet flushing systems. So our state opted to go with only allowing systems that are certified by NSF. That's National Sanitation Foundation, and they have a certification process called NSF 350. And manufacturers can go through that certification process, and I'll talk more about the systems that are allowed through that. And then if they achieve that level of certification, then they could be installed in homes in the state of Colorado. The difference between the category C and D, when you have multi-residential or commercial systems, those have to be designed by a professional engineer. And also the state health department wants to maintain a free chlorine residual between 0.2 and 4 milligrams per liter in this treated water to ensure public health and safety. Okay, so this is, there we go. Okay, so this is the NSF 350 certification requirements. So what we have here is, again, NSF is an agency that certifies products to meet health standards, and they have a particular certification process for these household scale gray water systems. And they also address some commercial systems. So for example, the class R that you see here is the residential systems, versus the class C are systems that are between 400 gallons per day up to 1,500 gallons per day. So those are systems that would be larger than a typical single residential unit, and the standards are a little bit more strict for those systems. So these are the water quality requirements for those systems to meet. So you see organic matter is CBOD, we have turbidity, E. coli, that's the indicator organism to ensure that there's enough inactivation of pathogens in the system. And then we have residual chlorine. Our state has made a more strict requirement for residual chlorine than this one. So, so basically what happens is a technology provider or supplier of a gray water system would have to put their system through this testing, and NSF has a recipe of gray water that they have to make, and then they have to show that their system meets these standards for a particular period. I think it's 3 or 6 months that they have to show that it consistently meets these standards in terms of the average and single sample maximum requirements. So there's not too many systems available that have gone through the certification process. There are a couple. So these are 4 technology providers that have systems that are NSF certified. So these systems are all ones that could be installed in our state in a single residence. None of these systems are designed for or certified for the multi-residential or commercial scale. So we're still lacking in our ability to be able to install systems at that scale, but these are all systems that could be installed in a residential household to allow gray water use for toilet flushing. Clearly here, we're dealing with systems that are a lot more complex than what we were looking at for the gray water irrigation systems. So potential for maintenance on these and higher installation kind of costs as well. Okay, so when we are using gray water to flush toilets, the storage tank and the whole system design really has to be a little bit more complex as well. So the reason for that is that toilets need to always have a water supply. So the systems need to be also connected to a municipal or potable water supply. And therefore they need backflow preventers. They typically have some kind of valves and switches that enable when the water empties for potable water to get into the tank to supply toilets. So not only are the treatment systems more complex, but also the storage tanks and distribution of water gets a little bit more complex as well. So this kind of shows the process that can be involved with all of that I just talked about. So for example, one of the systems that we designed for a residence hall here, this is how it worked. So we have maximum tank level, and as water was used in that, would be used in that tank down to a certain level, a gray water valve would open, and then gray water from a storage tank would come into the system. It would be dosed with chlorine on its way into the system. So then we have a full tank again, and that water can be supplied out to the toilets. Now, what happens though if there's not gray water to come in, The gray water, if the gray water valve opens and no gray water comes in and the water continues to empty, then you have a potable water valve that opens and allows potable water into the system. But what that does mean is that you need to take care of potential cross-contamination of your potable water supply. So there's a lot of plumbing and safety code that has to be followed with these. So there is in our International Plumbing Code specifications for how to do these kinds of systems. That's a 2012 International Plumbing Code, or IPC, that you see there that our state has adopted. And for example, backflow prevention is required, and you can see a photo on the right there of a backflow preventer. And what that's going to do is just make sure that no gray water from your system can enter into your potable water supply. There's other requirements too, like having a closed top on the tank, having vents, drains, overflows, all of those kinds of things. So those are all specified in plumbing code that's adopted here in the state of Colorado. Like I said, we can also have these systems for multi-residential or commercial kind of applications. There's a lot of buildings coming up in the cities of San Francisco, Los Angeles, Portland, Oregon, Seattle, that are adopting these kind of really large-scale urban buildings that have gray water reuse systems or wastewater reuse systems in the building. And so there you collect a large amount of water through the building and treat that and supply it back for toilet flushing. This is a picture of what one of those systems can look like. They typically would have a lot of online monitoring and controls and a little bit more treatment, like we said, because there's a larger number of people that can be exposed through those kind of systems. So I did just want to include also what a system like that could look like. Okay, so in summary, use of gray water definitely has the potential to reduce demand for potable water. So we're taking, because half the wastewater in a household is gray water, that gives us a pretty large source of gray water that can be then used to meet these non-potable demands like irrigation or toilet flushing. And Regulation 86 is now in place to allow for use of gray water for both irrigation and toilet flushing. That regulation does allow these laundry to landscape systems that are really very simple and don't require a lot of retrofitting in the home. So it's really a practical way to get started with a gray water system if a homeowner is interested in doing that. And then just looking at the impacts to soil quality and plant health, no major concerns have been identified for using gray water, just as long as those best practices are followed for use of gray water that limit human contact and drainage off the property and things like that. Then also systems can be installed for use of gray water for toilet flushing. Those systems do a great job in reducing demand for potable water, but they are more complex, and particularly at the household scale, for some homeowners that could be impractical. For other homeowners that would like to take on that challenge, there's some options available to do that. Okay, and this picture actually shows the first gray water person hole that was here in Colorado, at a constructed wetland that we had an operation for treatment of gray water. And that's a photo of Dr. Larry Rossner, who I mentioned earlier, for his efforts in the gray water as well. So with that, oh, we can take questions. Yes. You see that? Yeah, so what about gray water irrigation in the winter when plants are dormant? So really, you should operate a gray water system just how you operate any any irrigation system. Just like in the fall, you come and typically have a blowout of your irrigation system. You should do that when you're using gray water as well. And that's why it's really critical to have a connection to sewer. So over the winter months, when the ground is frozen, you shouldn't be applying gray water to your landscape, and should be instead diverting that to the sewer and following all the same practices that you would for for a blowout of a typical irrigation system. So likewise with the laundry to landscape systems, they've got the valve, so you would shut off that valve over the winter, and also just to make sure those distribution lines didn't get frozen, you'd want to blow those out as well. Okay, so next question is, any local inspection required for gray water systems before they're activated? That is going to depend on the local jurisdiction. So like I said, the legislation for gray water allowed for cities to either adopt ordinances to allow gray water or not. I know that in the city of Denver, where they've adopted that ordinance, they do require an inspection of the gray water system. The plumbing of any house needs to be inspected. So that's something that always has to be conducted, is for a certified plumber to come and inspect the plumbing of your gray water system and all of the plumbing in a home before it's lived in. With the specific gray water system, I think most of the cities would probably have someone come out and look at the system before that it could become operational. Okay, so next question. Did you look to see how the mulch ring demonstrated earlier in the presentation affects root growth and water retention for young trees? We did not actually include one of those mulch systems in our study that we did, so I haven't directly collected data on those. However, I've seen some results from a pilot project that was done in Long Beach, California, where actually a whole neighborhood, about 10 or 20 households in a neighborhood, as a pilot, installed these laundry to landscape systems. And many of the trees that they planted were young trees. They planted, a lot of people re-landscaped their homes when they installed these systems, and those all did really well. I can say in terms of the water distribution, the way that those are designed is that they really distribute water well throughout the entire soil area and into the tree roots in the areas where they're present. So I have not seen any problems with respect to getting water to access roots in areas where those mulch beds are. Okay, so can you speak to how antimicrobials and salts might affect soil microbial health long term? So I'll take that one first. The antimicrobials could have an impact on soil microbiology. We did some testing on respiration and things and could not find a direct correlation between the antimicrobials and microbial health. However, there's certainly that potential if the antimicrobials accumulated to a high level, and then we have to also worry about, or not worry about, be cognizant that these antimicrobials could result in antibiotic resistant genes and more transport of antibiotic resistant genes in our environment and to humans, and all of those kinds of concerns that we have with antibiotic resistance. Therefore, I think, really recommend that those using gray water and any products really don't use products that contain antimicrobials. The salt impact for microorganisms, that's not a concern. The salt does not accumulate to the point that it impacts microbial health. In fact, we found that soils irrigated with gray water had better soil microbial activity compared to soils irrigated with some sort of freshwater source. So that's really not a concern. It becomes more sensitive for plants before it becomes sensitive for microorganisms. How quickly do antimicrobials biodegrade? A lot of the antimicrobials are not biodegradable, maybe partially biodegradable. So that's where we saw more accumulation compared to those surfactants and other soap products that were biodegradable. So we can't really rely on the antimicrobials biodegrading. How many years of research are these conclusions based on? That's a nice question. So that study included two types of households. So some of the households, a requirement for their selection was that they had their graywater system operating for at least 5 years, and then we collected samples for 3 years subsequent to that. And some of the other households that we studied, they installed a new graywater system so that we could actually collect baseline samples and then monitored for 3 years after that to see how the soil changed when they installed. So we had 5 households where we had more than 5 years of graywater irrigation, and that's definitely where we saw more of the salt accumulation, is after the long-term irrigation. Many of the households, some of the households we studied even had their graywater systems operational for more than 10 years. So there was a variety of households, but some of those I think really did characterize long-term impacts. Okay, so we have another question. Boulder County used to allow graywater use on a case-by-case basis. Since Regulation 86 has come into play, Boulder County no longer allows any graywater use. What is being done to encourage cities and counties to adopt local regulations that will allow for the use of graywater? This is an unfortunate reality that I've seen throughout our state, is that actually the passage of Regulation 86 and the legislation has really put cities in a point where I think that they have to do some work to create these ordinances, and a lot of cities, although very interested in doing it, have not had the time and resources to do so. This is, I see this kind of happening throughout the state, and I don't think that was at all the intent of the legislation or the regulation. However, it's a reality that we're dealing with. I think that one of the things that we can do is to provide some guidance and information related to setting up these local ordinances for cities to use, because I think a big part of the holdup, like I said, is that a lot of the cities just don't have the time to put into developing these ordinances, even if they do want to promote graywater. And so that's just kind of putting a burden on them. And I think a really good way would be to hold some workshops and educational activities around and develop model ordinances that would make it really easy for cities to get these programs in place if they would like to do so.